So let's solve another kind of problem based on the projectile motion. The question is, water flows from a drain spout with an initial velocity 0.8 meter per second at an angle of 18 degree with horizontal as shown in the below figure. So figure is given here. Determine the range of values of distance d for which water will enter the bucket CD. So this is the given figure. So here let's find what are the given data. So here if you look into the figure, this is u with that velocity it is moving or it is projected, and this angle of inclination we have denoted as alpha is given. Then next is there are two cases now. See, what happens here is either this water jet will enter through this point. If I call this as A and this as C and this as D point, either this water jet has to enter the bucket through point C or it has to enter the bucket through point D. That means along horizontal axis it has to travel two distances, that is either it has to travel x1 distance or it has to travel a x2 distance. So this x1 is D and x2 is what? It is D plus 0.7. In both the cases it is different. Okay, so this is the given question. Let's write there are two cases as this water jet has to travel two distances. So if I write the data for the case 1, for the case 1 the data is u is given, that is 0.8 meter per second, alpha is given 18 degree, x is what here, x is d1. Okay, let us call that as d1 for the case 1. And what is y? So that is next question, what is y? So here y is the difference between the point of projection and the target. So point of projection is here, somewhere here it is, the difference in the height, the target is here, that is point C. So this is the y. From here to here it is y, and this y can be calculated 3.2 minus from ground to here is it is 3.2 minus, and the height of bucket is 0.4 meter, it is 2.8 meter. So y is equal to 2.8 meter. Now the jet is traveling from higher point to the lower point, that is in the lower direction, that is in the downward direction. So y is minus 2.8 meter. And one more thing is, our assumption is that if the velocity is moving in the upward direction, then in that case the angle of projection is positive. If the velocity is moving in the downward direction, in that case the velocity is negative, sorry, the angle of projection is negative. So here it alpha becomes minus 18 degree and y becomes minus 2.8 degree. Then next for case 2 the data available is, for case 2 the data available is, that is it is moving with the same velocity 0.8 meter per second, and alpha is also same, that is minus 18 degree. Now here x is replaced by t plus 0.7, and what is y? Y will be same, that is minus 2.8 meter. Writing this is very important. Then after this rest of the thing is easy, that is using some equations, some standard derived equations. Then we have to substitute all these values in those equations, we will get the unknown value. So as here, if you look into this one again, the relation between x and y is known to us. So I can use the equation of a trajectory. So using that one, I am writing here as relation between x and y is known. We can use equation of trajectory for both the cases. So for case 1, the data available is this one. For case 1, the available data is u is equal to 0.8 meter per second, alpha is equal to minus 18 degree, x is d1 and y is minus 2.8 meter. So let us substitute this in the equation of trajectory, that is y is equal to x tan alpha minus gx square upon 2u square 1 plus tan square alpha. So here all the values are known. It is minus 2.8 is equal to x is d1 here, tan minus 18 minus 9.81, and again x is d1 square here upon 2, u is also known, that is 0.8 square plus 1 plus tan minus 18 square. So we have to simplify this equation. On simplification it becomes minus 2.8 is equal to minus 0.325d and minus 8.473 d square. Now it's a quadratic equation. So on solving this equation we get d is equal to some value. So after rearranging the term, it is 8.473 d square plus 0.325d minus 2.8 is equal to 0. Now on solving in calculator we get two values because it's a equation of 2 degree. So we get two values of d. We have to neglect the minus. Okay, we have to neglect the value which has negative sign and we have to consider the positive sign. So the value with positive sign is 0.555 meter. So this is d1, that is one of the distance at which the bucket can be placed is 0.555 meter. Then let us find another d value for the case 2. So the data available for case 2 is this one. So first I will write down here, that is for case 2, the available data is u is 0.8 meter per second, alpha is minus 18 degree, then x is what here it is, let us call this as d2 plus 0.7 or and y is equal to minus 2.8 meter. So this is the available data, and as in the case of the case 1, here also the relation between this x and y is known to us. So I can use the equation of trajectory, that is y is equal to x tan alpha minus gx square upon 2u square 1 plus tan square alpha. So substitute the values. Minus 2.8 is equal to, what is that, x? X is d2 plus 0.7. I have written here it as d1 and here it as d2 just to differentiate that one. So, and it is tan minus 18 minus g is what? It is 9.81 multiply with d plus 0.7 whole square upon 2 multiply with 0.8 square, and this has to be multiplied with 1 plus tan square minus 18. So here on simplifying this becomes one quadratic equation, and on solving that one we get this value as minus 0.144 meter. Okay, as we know distance cannot be minus, so d cannot be a negative value, therefore the range of d is 0 to 0.55 meter, and this is the answer for the question.